Hello. Yeah, hello. Welcome to the session. So, I have already loaded all this workspace, my workspace. So, I'll open the community edition for Databricks. So, and I'll open the first chapter. So, let's open that first chapter in the Databricks community edition. So, just be patient. Yeah, let it load. It is taking a few more times. So let's wait. Yeah. So before you start the session, it's a kind of hands-on session. You can also subscribe the Databricks Community Edition and just import the workspace and start working on that. So Databricks is one of the company which is the original creator of Spark and PySpark. They created a company called Databricks, and they have the creator of the data lake, um, the extension of PySpark, and for creating the lakehouse architecture, they are using the Databricks, a Databricks cluster. So before we start the session, so we have to sign into Databricks community cloud platform so that you will have the um, a limited resource available to start your learning. So yes, for getting all these, you need to sign up with Databricks, and once you sign up, then you import these uh, Databricks archive, all these lessons and start creating. So a Databricks cluster is a set of computation resource and configure on which you run data engineering, data science, data analytics workloads such as production ETL pipeline, stream analytics, ad hoc analytics, and machine learning. So if you start the Spark architecture, you can see the Spark can support all these um, it has a structured streaming, it has a machine learning interface, and it has a Spark SQL. So these are the data science, data analytics. So learning objective. First of all, we need to create a cluster. So for creating a cluster, we have to open the create button. So in the create, there are three options. One is notebook, one is table, one is cluster. So you need to simply select the cluster. So once you have to create a cluster name. Let's say cluster name is demo one. So let me um, create a cluster. It has a runtime. It is the recent runtimes. It has multiple versions available. Databricks versions you will have. So let it select the default one, and the instance is a free 15 GB memory as a community edition. You cannot ask for more than that. So for that you have to upgrade your plan from pre-community to one paid subscription so that you can use that. So I'll click on create cluster. It will take good amount of time to create a cluster and attach that cluster to your Databricks notebooks are attached to the cluster to your account. So hopefully this will complete. And sometimes it gives some error if the behind the scene it is using a lot of things. It is creating a um, driver node, then it will create the worker nodes. It will be some driver manager will be set up. So everything can be set up, and once it is done, it will be available, and you can attach your notebook to that cluster and start executing the um, Spark programs, or play with the different Spark programs, right? So so instead of that, I will go to the let it create, and by the meantime we can um, open our so Databricks Spark itself support to four different language API. One is your Java API, one is your Python API, one is your R API, one is your Scala API. So mostly, so out of box, again Microsoft has created a .NET API where you can interact with the Spark with .NET API. So a lot of community work is going on. So by the end of few years, it will support some more languages, programming languages or APIs through which you can interact and process the data through Spark. So one of the most common because Spark is itself is written in Scala. Scala is native to Spark. A lot of things you can create in Spark using Spark in Scala using Scala in Spark. But there are huge opportunity to work with the Python, because Python is bit easy, and many people, even if people are not coming with the data background, they can also write programs and write small Spark program by Python programs. So that is one of the advantage. So that's why Python is very popular in with Spark, and Databricks is no option. Databricks is made upon the Spark. The behind the scene, it uses Spark engine to process the data, and the outer interface, it has given lot of easy way to interact with Pythons. Let's say Spark SQL it has created, and upon that it has created Spark is a big data processing engine. But here by Databricks has given you the opportunity to work with the kind of transaction table. So it has made a platform, a lakehouse platform. It has the provision of data lake, the traditional data lake, and even if the warehouse, both are integrated. So it really support a lake house architecture. So both it can support AI and ML kind of workload, and the data warehousing workload, and keeping the data in a single source of truth, or in a low cost storage like S3 or any object storage, either in Azure or any other cloud platform. So let's check. I think let's open the compute. So we see the clusters. We have a cluster name is demo one. Its runtime is 10.4 Databricks version, and the active memory is max 15 gig as a community edition, and it has a two core, like uh, two executor. You can say you can get it. So here you will get a lot of options to manage, like restart, clone, delete, everything you can do it. So so before wasting our time in this, let's execute the first notebook in our course. So let's open it. So all these lessons are about how to create a cluster and single load cluster for this course, because our aim or objective of this course is not a build a high performing storage or high performing programs. Instead, we'll get familiar with the Databricks Community Edition. The website is looks very slow, so let's. So this notebook is primarily mean developing, executing code interactively with the Databricks. This lesson provides the basic introduction to working with Databricks notebook. So just a familiarization, use how to use the Databricks notebooks with the cluster and in the community editions. So that is the main objective of this course. Um, so let's say how to run this. So just let to execute this. Let we have shift enter. So before running any, so this notebook is not attached to any cluster. Let me attach this cluster to. This is showing detached. So I selected the demo one. So now this demo one cluster is attached to this notebook. So I'll start executing this print statement from this. So you can see this updating the uploading the command, so that this command I'm running Python. So this is just a print of a statement, so that we can verify this is attached. And we have created a SQL cell also. Mm, this is a markdown cell. So yes, let us, this is a code example, so we can use the shift enter to execute this. So command 11 we can start executing. This is just a print statement, so it will print hello Python. This is not just learning, just make you familiarize with how we are executing the code in the Databricks environment. So if you, even if you can execute a SQL like this, just give a magic command percentage SQL, then start executing that. So let me, this is Databricks program. So they have their set of files. So once they executed, then a demo tab view we already created in this. So let execute that SQL, select star from any table using this SQL command. So then let's wait. Let it execute. So you can see there is a table or a view, demo temp view, where we have two columns. One column is name, one column is value. So this you can see the result of that. So we'll use the setup notebook through course with the help of Confluent. So there are the cell below in Python print some of the variable previously defined in this notebook, like print DA username, what is the username, what is the um, path, and what is the database name. Current user is Subrat Parida at epsilon.com. Working directory is dbfs user Subrat Parida epsilon.com, DB Academy DU and 1.3. Database name we can create it. Database utility, even if we can use some utility to, like DB utils is a kind of command line tool through which you can see the files, Databricks dataset. Uh, what are the data sets available in this for this course. So behind the scene there is a Linux server, and in that path DBFS Databricks dataset we have so there is a display command. Even if yeah, you can use that display command. When running SQL queries from cell, result will be always be displayed in the rendered tablet. When you have a tabular data returned by the Python